All right, I'm going to leave it at that. Our speaker tonight is Sydney Runkle. Sydney is new to Boston, but not new to Python and not new to Pydantic, but she knows all about Pydantic, and she's going to tell us about it.
Hello, as Ed said, my name is Sydney. I moved to the Boston area in September. I've been really enjoying it thus far, and I'm excited to be a part of this group and get to share all about Pydantic with you all. So just a quick table of contents here. I'll give a quick intro talking about myself, go over some Pydantic basics. So if you haven't used Pydantic before, this talk should still be pretty friendly to you. I'm going to kind of the meat of the talk is the why use Pydantic section. That'll have kind of features and things like that. Then I'm going to talk a little bit about the Pydantic architecture, which will probably be interesting to you if you're interested in performance or just kind of the melding of Python and Rust that we have in our code base. I'm going to talk a little bit about Pydantic AI, which is our newest open source library that we've been working on at Pydantic, which is also a company. A little bit confusing, we have Pydantic, the open source library, which many of you are probably familiar with, Pydantic AI, our new open source library, and then we are also developing commercial observability tools, which I'll talk about at the end. That is sort of the sponsored part of the presentation. And then I'll have a conclusion and Q&A. But I like taking questions during the presentation. I think people are more likely to ask questions as they come up and get those answers than if they have to kind of save them and remember them until the end. So feel free to just raise your hand at the end of a slide. Okay, I'm going to do the intro. You can't see it, but that's okay. Okay, so I'm going to say long-time small business developer. That might be a little bit of an exaggeration given my age. But I've only ever worked at small businesses, if you exclude scooping ice cream at Ben & Jerry's in high school. I'm currently the lead Pydantic maintainer. I've been doing that for a year and a half, maybe close to 2 years. And I love it. Working in open source is a really unique opportunity, and it's kind of a cool way to get to have a lot of work be public and connect with lots of people from all over the world, and then also face some, pretty challenging technical problems. If I am not working, even if I'm working, I'm probably at a coffee shop. But I spend a lot of my time doing that. Boston's a great place to do that, so if anyone has any particularly good coffee shop recommendations, definitely let me know at the end. Outdoors enthusiast. I'm biking at Walden Pond in the bottom photo there. I'm outdoors most days, either running or biking or swimming. I do triathlons. I bake every week. I have a blog post where I talk about the fact that I can get myself to bake every single weekend, but cannot get myself to write my blog posts every single weekend. And then I also love podcasts. In particular, I love political podcasts. So this is me graduating from the University of Wisconsin-Madison in the spring, and then to the right is my partner and I in Seaport, and then me enjoying some coffee. I'm guessing there aren't questions yet, but any questions?
Why didn't you bring baked goods?
That's a good question. I should next time. I made a lot for the Super Bowl, but they were all consumed. Okay, so let's talk about some Pydantic basics. What is Pydantic? I'm going to be saying Pydantic the whole time. I mean the open source library Pydantic. If I'm talking about the company, I'll clarify. So Pydantic is the most widely used data validation library for Python. What does that mean? Great question. So here is kind of the bread and butter Pydantic example. We import base model from Pydantic. We use base model to define this user class, and then we use type hints, like native Python type hints, to specify the types of the attributes of the class. So we see a user has a name attribute, intuitively is a string type, and then some sign up timestamp that is a date time. And Pydantic's job here, when you subclass from base model, is to perform validation on your data based on the type hints that you've given it. So here we get in this external data with a string form named John Doe, and then also a string form sign-up timestamp. And when you initialize that class with the external data, Pydantic validates that. So Python is a dynamically typed language, not statically typed, so types aren't actually enforced. But what Pydantic does is kind of acts as this like drawbridge between the like dynamic Python land and this like enforced types land that you kind of control. So you still have all of the flexibility that Python provides, but you get to control some of the data structures. So yeah, I'm printing the initialized user, and you can see we have John Doe, and then also interestingly now, a date-time instance. So Pydantic did all of the hard work for you to confirm that that date-time string was actually a date-time. So on the previous slide, I said Pydantic is the leading data validation library for Python. Validation is, in a sense, correct, but it's also not, doesn't fully explain everything that Pydantic does. Pydantic also does, as you can see with the sign-up timestamp, coercion in certain cases. You can kind of control and configure how it coerces things, but that's sort of the hard work that it does in the background for you. Okay, so I have up in the top right that like user model. I'm going to use that for the next couple slides. This slide kind of shows the value in the validation, which is you get really, really helpful and predictably structured errors if your data is not structured in the way that you've specified. So in this example, once again, using the same user class, we provide a name. It's now not a string, and we forgot to provide the sign-up timestamp. So Pydantic tells us exactly that. Name, input must be a valid string, sign-up timestamp missing. You can imagine, I'm guessing, many of you work with data. Sorry, I'm not sure what's wrong with the slides. So it's really valuable to be able to validate it and then kind of have this predictable way to confirm that it takes the structure. Excuse me. That's not. Anyways, so basically value coming from validating the types of the data, and then not just doing that and telling you like yes or no, this was the right structure, but also providing you with pretty detailed feedback. This is really helpful for the case when you're like getting in external data and ingesting it and trying to make sure that it conforms to some structure that you have. You can kind of confirm or deny whether or not everything takes the appropriate shape. One other really nice feature of Pydantic is that it is type safe. So what do I mean by that? You basically get hints and information from your IDE or linters or type checkers like Pywrite about your data structures as well. So here we have the like flawed external data again, and then I ran Pywrite on this, and it's telling me that name can't be an int, because again we specified it as a string, and then that sign-up timestamp is missing. So you get this runtime validation, but then also beforehand you can get kind of hints. Okay, why use Pydantic? Any questions kind of about those introductory examples?
Yeah, when you showed the example before, the date time was a string,
Yes.
and yet it converted it to a date time.
Yep.
Why isn't it converting an integer to a string?
That's a great question. You can configure that. So we assume that most folks want to have a little bit of a more strict pattern for like integers to strings, but we have a setting that you can set that says like, yes, coerce its to strings. So we try to offer like by default the behavior that we would expect the majority of users to want, and then also I'll touch later on like an abundance of configuration options that kind of let you play with the temperature there.
Quick question.
Yeah.
I haven't used Pydantic till now, but whenever I deal with, the data I deal with is like huge in scale. So how does this sort of apply there where like, let's say I have to call an API and ingest into a table. There's like 10,000 rows that are coming in. How does that work in conjunction with Pydantic?
Yeah, sure. So basically you would define your data structures associated with the table. So maybe you would have like, you have a row that's associated with the user and maybe it has 100 columns. Like you can define that data structure, Or you can also define nested things. So like a user could have, I don't know, a list of friends that are also users or things like that. So you basically define the schema of your data, and then you can ingest data and validate at a really large scale. We had Pydantic V1, which was like our original version, and then we just switched over to V2 a little over a year ago, and we rewrote the core of Pydantic, so the like validation logic in Rust, which made it much, much faster and much more capable of those like large scale ingestion things. Yeah.
Thanks.
Most of your examples show basically converting it to an object from something like a JSON string / dictionary.
Yep.
Do you expect that that validation step occurs when it gets changed to an object? Do you expect that then people will then use that object to like pass around things, or is the expectation that, okay, well, I validated it by using the object, and I'm going to continue to pass it around as a dictionary?
Yeah, great question. So I think the answer is it really varies based on like different folks' use cases. So we kind of allow for any of the above. So you can ingest data either from like a Python dictionary like we've shown here, or JSON data. You load it into that like intermediate Python object, and then you can also dump it out to a Python dictionary or JSON data. And so if you kind of want to just like validate and then send it back out to a dictionary, you can definitely do that as well. Yeah. Alrighty. So now I'm going to talk about why you should use Pydantic. Don't take it from me. Take it from all of these companies that are using Pydantic. Specifically, my favorite stat recently is that we are now at 300 million downloads a month. That's a lot. 20 out of the 25 largest companies on NASDAQ use Pydantic somewhere in their tech stacks, and then all of the FANG companies pretty extensively use Pydantic. All of the like Python SDKs, OpenAIs, Anthropics, etc., often use Pydantic. We've been working with a lot of those in our Pydantic AI development recently. Google just released a generative AI SDK in Python. There are Pydantic models all over that. So I think kind of you can take it basically from the industry standard as a like ringing endorsement of Pydantic, but beyond that ringing endorsement, I'll tell you a little bit more about like feature-wise why it's great. Alrighty, as I mentioned, Pydantic is powered by type hints. So we had that like kind of introductory user example before with our string type hint and our datetime type hint. You don't need to understand what all of this means, but basically the point of this slide is to show you that you can use a very, very wide variety of type annotations to tell Pydantic what structure you want your data to take. So maybe you have a string, maybe you have a date that is sometime in the future, which we conveniently provide for you. I have a student model, maybe the student has an age, but they should probably be older than 18, maybe greater than or equal to, perhaps. They have a grades list, which is this more complex data structure. And here we're starting to use kind of more complex types from the typing module, or annotated types. Once again, you don't need to necessarily understand all of these, but I think the main point is like, whatever structure your data holds, if you can find a way to represent that type, Pydantic can probably validate it for you.
So GE and LE are just greater than, equal than,
Yeah.
less than or equal?
Yeah, so GT is greater than, GE is greater than or equal.
Okay, thanks.
Yeah. So those are just like convenience annotations. This like annotated syntax for type hints is relatively new, so a lot of folks aren't familiar with it, but we use it a lot at Pydantic because it makes it easy to kind of have a type and then attach metadata or constraints.
Is that from standard library?
Which,
The annotated types is from standard library, or is it?
no. But pretty like endorsed, and I am pretty sure, like 90% sure. Okay, why else should you use Pydantic? It is very, very fast. Specifically, the validation and serialization logic. We have our core written in Rust, and so any of those operations, unless you're writing custom functions in Python, take place in Rust and are very fast. I'll touch on this more when we look at the like architecture of Pydantic. but when you take your data from like raw data, then you validate it into this Python structure, and then you dump it back out. Both of those like transitions are done in Rust. Also, just a note on continuous optimization. We take performance really seriously at Pydantic. At Pydantic, the company. I have basically spent my last couple of months trying to optimize startup times for applications that use Pydantic, because we eagerly build kind of the schemas that define your data structures, and we want to do that really quickly. So we do things like, having benchmarks throughout our code base that we like test on every pull request, and things like that to optimize said things. We also do that in Pydantic core. So we just merged a pull request this week that reduces memory usage taken up by those schemas by like 5x. So that is coming in our next release in March, which is exciting. But basically the points on speed are like, it's already fast, and we really care about making it faster. So you can kind of trust us to continue to work on that. Yeah.
Good question. Was it originally written in Rust, or was it ported?
It was just Python for V1, and then we like took out the like middle chunk of it and made that in Rust for V2.
I see.
Yeah. So now what we're working on is like really optimizing the like Python outer bits. Okay, I'm gonna dive into more kind of like features now. So Pydantic models support JSON schema generation, which is used to be super relevant for API docs, and absolutely still is, but is increasingly relevant for generative AI applications. You can feed your LLM's JSON schema and tell them that you want that to be the structure with which they return data, and they try to do it. Sometimes they mess up, but here's our student model, sort of the complex one, and then you can see on the right, perhaps in very small text, the specifications of this model. So again, a note on like automatic API documentation. A lot of people are really familiar with Pydantic because of its adoption in Fast API. And so you define your request and response structures with Pydantic models, and then that's used to generate JSON schema, which is compatible with OpenAPI, the OpenAPI specification, which then can be used to automatically generate API docs like Swagger, things like that. And obviously, the easier it is to generate like up-to-date documentation, the better. So.
Is there any way to encode the current date and the future date generation there?
Say again?
So the future date, the graduation date method there doesn't have the current date. So it doesn't really know. It needs, for example, an LLM might not know. It needs to generate a future date.
Yeah.
So
Yeah.
can you enforce that?
Great question. So I guess we don't have that built in for, under the hood, this future date is actually like an annotated date with constraints. But you can customize JSON schema generation with Pydantic. So you could say like, hey, I want this future date, also add this one attribute to the JSON schema. With an annotation, or I'll touch on fields in a bit. Okay. So the great power in Pydantic comes from its customizability. We try to give you this structure with which you can develop and be confident in your data, and then we send you off to build custom validators and things like that that really suit your needs. So I have this number as a part of my model, and I want to determine if it's even. It's very easy for me to write a validation function that takes, I'm specifying that I want it to apply to the number field, and then I confirm whether or not the number is even or not. I'll touch on the mode of the validator shortly. But just to kind of show what this looks like, we're going back again to what the validation errors look like. So here, 1 is not even, so we get this like nicely formatted error. Obviously, the is even check is quite oversimplified, but you can imagine your applications are going to have really special needs for data validation, and so it's really easy for you to write that code. One note on the mode here, we offer 3 modes but 3 important ones for validators and serializers, which I'll touch on shortly. Before, after, and wrap. So before means, before you even send my data to Rust, I want you to do this like pre-processing on it. After means, I want you to validate it in Rust, like make sure you're giving me an int, for example, and then I'll do things with it. And then wrap means I want an abundance of control, I want to pre-process, and then I'll send it to Rust and get it back, and then I'll do some post-processing. So once again, just value and configurability here. The fourth one that I am kind of avoiding is called plain, and it just means don't send it to Rust, I'm going to do everything. Okay, so I've been talking about these annotated types a lot. Here we have the exact same thing. I've defined my isEven function, and then I have my annotated integer with the after validator metadata. This will all be applied in the same way, and you would get the same error if you pass in invalid data. You might even take it one step further and say, you know what, I actually have tons of even integers all over my code base. I'm going to just define even int equals and then this annotated type, and then you can reuse that everywhere. Yeah. Okay, last thing on field validators. You might find it really helpful to get extra information or context, right? Like maybe in your custom validator, you want to know what the field name is so that you can write a more helpful error message. Or you want to get, in this case, some context information that maybe you don't know until runtime, and you want to kind of dynamically plug that in. Well, our validators are great for that. So here's an example where you're passing in some text, and then at runtime you want to pass in some stop words to remove from your text. Maybe you're trying to extract important words, but you don't know which words you're going to extract until late on in the process. And then you can see this should be like commented out. That's kind of the result. But again, an after validator here for simplicity. Model validators are also something that we offer. So it's helpful to validate individual fields and the data that they contain, but often you want some sort of like consistency or certainty across different fields in your model that they like match well together, for example. So in this case, we have a user model. They signed up with a username, a password, and then they typed in their password again. And you can use this model validator to confirm that the passwords match. We have the same mode types. So this currently looks like Pydantic does all of the validation of your model, and then at the end we pass through the data and say, do the passwords match? Okay, I have talked a lot about validation, which is more popular, but serialization is important too. So again, that's that step from going from your structured Python validated data to either JSON or a plain Python dictionary. We offer custom serialization as well. So this like model dump command is how you get from your Python data to that raw data. In this case, I have just kind of a toy example here where like maybe you want to serialize your courses as a string instead of a list of strings or set of strings. And so custom serializers allow you to do that as well. For brevity's sake, I've just included a field serializer here, but you can imagine they have all the modes, all the like model field customizability as well. Any questions on that, like abundance of technical content?
Are those contexts, is that state you can update as validation proceeds, or is that kind of on a per field basis?
Yes, so it updates as validation proceeds. We actually have the information about previously validated fields in there as well, if you want it.
Yeah.
So that would be like another approach to take for the like password match one, is you could pull that previously validated password out and validate there.
Thanks very much.
Yeah. Okay.
Excuse me, I did not understand what does previously validated mean?
Sure. So in this example with the passwords, we would kind of validate consecutively here. Like first, we're going to validate that the username data is a string, then the first password on line 8, and then the password repeat on line 9. So theoretically, if you write a custom validator, field validator for password repeat, you could have access to the data that had already been like confirmed to have said types.
Like the self.password repeat, or another way of looking at
Yeah, so
previous validation?
I was sort of like abstractly talking about another way to do it. there are like more concrete examples in our documentation. It would look a little bit different than this, but yeah, it's a
Okay.
very
All right.
similar idea.
Thank you.
The idea is if you did a like field validator instead, you wouldn't have self ready yet, but okay. One of our most popular tools that folks use called aliases. And so aliases are when you're validating data or serializing data, do you want to look at different field names? So this is really relevant for basically the case of trying to use snake case for best practice in Python. So I want to use like important underscore data because that's how attributes are supposed to be named in Python, but my incoming data uses camel case, and then my data that I'm sending out uses Pascal case. So I can see I validate my important and then capital D data, and then my validated model has important underscore data, and then when I dump things, I get my capital I important capital D data. Very helpful, basically, just for adhering to standard Python conventions and not having to write custom validators that do things that we know you already want to do. Okay, how do we one-up this already helpful alias thing? You might have a lot of data coming in camel case or going out in Pascal case. And so instead, you can use our configuration dictionary, which is also where you can do the integer to string coercion. You can do lots of things in the configuration dictionary. Here we just say, you know what, every field, the validation alias is going to be whatever I said, but it's camel case, and then same with Pascal case. And then here's kind of an example of that. Like my data is coming in with that kind of alias format. Then we validate it into the snake case and then send it out in Pascal case. So also helpful for, in particular, API development is where I see this the most. If you're interacting with like APIs that are designed by developers using other languages or just other standards. Okay, I was just talking about configuration. Don't worry, you're not supposed to be able to read this. That's kind of the point. So we have two kind of levels of configuration. There's the config on a model, which we just saw. Like I want to set my aliases for all of the fields on the model. And then there's also configuration for individual fields, which is what I'm showing on the left here. So again, beauty in Pydantic is like, this is extremely configurable, and we try to make this as easy as possible for you. I'll touch on a couple of the things that you could configure. At the field level, you can configure like numeric constraints, like I want this int to be greater than 10. You can configure like validation preferences, like the coercion. You can add JSON schema. You can, a little bit, specify a regex pattern that you want things to match. And then similar things at the config level, but do you always want to coerce strings to lowercase before you validate them? It's just going to make things easier. Do you want to defer schema build until later to get like a bit of a performance boost at build time? Sort of all across the board configuration. Any questions? Okay, I'm going to chat a bit about architecture, which is kind of the most performance focused part of this talk, but also will hopefully, with some diagrams, help you to understand the jumps that we're making from like data structures to validating things to like where is the rest happening. Okay, so you define your Python type user with the help of Pydantic, and then we are going to build what we call core schema, which basically just says like this is what your data looks like, and these are the constraints, etc. And that is with Pydantic core. And then we build these two structures, a validator and a serializer, that reside in Rust. And those are kind of like the powerhouse of Pydantic's applications. Also, just credit we have a brilliant developer, David Hewitt, who is a core maintainer of Pyo3, which is the like marriage layer between Rust and Python, and he helped with these diagrams. Okay, So if you're validating things, you have Python objects or JSON data coming in. We send it to the crustacean identified schema validator that's a Rust structure. And then we output validated Python objects. And so anywhere that the crustacean is in any of these diagrams is like very fast and working for you on that like batch processing speed. Okay, similarly, schema serializer. You have your validated Python. You can kind of imagine this as continuing from the previous slide. Then you send it to your very speedy schema serializer and then output the data format of your choice. So hopefully this helps, to kind of help you understand more of like what is Pydantic doing under the hood. Okay, I'm gonna pivot to chatting about Pydantic AI unless folks have any other like Pydantic specific questions. Yeah.
So those Python objects are fully instantiated before they're passed on to the
Yes.
Rust? Okay.
Yep.
Just more of an observation than a question, but didn't really talk about what is my key feature of Pydantic, which is the base settings, or settings in general. So I think you focus on the API use case, but it is also a core piece of all configuration management from my perspective.
Yeah, definitely. So we have a couple of like satellite projects that spin off of Pydantic. One of them is Pydantic extra types, which is basically convenience types for you that don't really fit under the scope of our like standard library, but maybe things like phone numbers or things like that. And then we also have Pydantic settings, which is basically Pydantic applied to configuration. And so it makes it very easy to load configuration from YAML, TOML, environment variables, etc., and then validate there. Pydantic also makes it very easy. I didn't showcase this very much, but if you want to set default values for things with the like standard default syntax that you might use with data classes, that's very easy, which also helpful for environment variables or configuration. I think that's like a very standard thing to be like, hey, look for this API key. If it's not there, it's okay. Just like don't make set of requests or something like that. But yes, very good point. We definitely get a lot of questions about base settings. So, yeah.
I'm very curious about like usage, like in which ways different companies are using it. And so the question I'm curious about right now is just, are most companies using it kind of at that point of unknown data coming in that needs to be validated, or is it ever used, or do they also use it internally for, describing types, kind of over, like is there any reason to use that above like a Python has that like type class library?
Yeah, the like type dicts or
Yeah.
data classes. Yeah. So I think we see a lot of both. Like I think early usage was pretty API focused. Now we're about to see kind of the like new hype around like generative AI usage with that structured data, specifically the JSON schema. But I think there's a lot of space in between for just like using it to make sure things are going well in your projects and like, ensuring that you can debug things well. So for example, like the OpenAI SDK uses Pydantic models just to like define the structures that you see. And that makes it easier for users to understand where things might go awry and that sort of thing. Another case that I've used personally is like when you're dealing with serverless functions, maybe you want to just use Pydantic models to define the structure of your like input and output just to make sure things are going well and have like very debuggable logs. Yeah.
Does Pydantic also ever create getters for the properties that are associated to the schema?
Yes, so good question. All of the properties, like we do fully initialize a Python object, but you can define like properties and setters and getters for those things based on the validated data. One future improvement that we're thinking about making, kind of in the name of performance, is storing the validated data in Rust until a user requests it with the getter or setter. Just, there's no reason to materialize it in Python until it's needed. I don't know if that quite answers your question.
But also I wanted to say like spectacular library. Does it, so like let's say I have some complex JSON schema and I use Pydantic to deserialize some API response. Do I have to access properties of this Pydantic, of this object that was instantiated by Pydantic directly, or is it possible for me to require that developers use getters and setters that are also created automatically by Pydantic?
Oh, interesting. Yeah, we don't create getters and setters automatically. You could probably like subclass base model and like add in kind of your own like requirements for that, or like I guess you might be able to do like a little bit of a hacky thing with a like model validator, like before you return this validated self, add these methods to it or that sort of thing. But we don't do that kind of natively.
Thanks.
Okay. I'll touch a bit on Pydantic AI, which, as I mentioned, is our new agent framework, very focused on developer experience, focused on being Pythonic in like nature and usability, and then also, of course, with robust like Pydantic integrations everywhere. So here's a very simple example. We're going to be like, Sydney, where's the Pydantic in this? We have an agent that is Google's Gemini Flash. I should have updated this to the 2.0 Flash, just came out. And then I'm asking it a question about where Hello World came from, and we return this result.data. Not super interesting yet. The next two slides have a good bit of code on them. So I'm going to try to do my best to kind of explain what's going on, and don't fret if you can't really see things. So the next two things that we're going to add to this agent level, which is still here, are dependencies and structured result types. So I've kind of already talked about the structured result types. That's where you define your result model, and then behind the scenes we're getting the JSON schema from that and passing it to the model providers. Now we're using GPT-4o and expecting that results are coerced into that structure. The dependencies are sort of things that you might want your model to know about when it's making tool calls or augmenting a system prompt or something like that. So I'll show kind of what that looks like on the next slide. Another benefit of having these Pydantic types here, agent is generic in both the dependencies and results types, is that you get all of those like type safe benefits here, which I think become, like from my perspective as a developer, increasingly important when you're dealing with generative AI applications where it's like hard to enforce types. The better job you can do on your end of like understanding the data that you're sending in, the data that you're getting out, the better. Okay, so what are we doing with these structured dependencies? We might augment the system prompt. So I put in some database information into the structured dependencies, and then I can augment the system prompt before it's actually sent with the customer's relevant data. So here we have like the name coming from the database, but you can imagine that might be more relevant information, nettings and things like that. Okay, customer balance. We're working with kind of a like banking agent here. This tool uses, again, the like support dependencies provided in the context. You can kind of see the like through line from, hey, we have custom model validators. Let's give users this like validation context thing so that they have more relevant information and can really customize there, to this point where we now have context available in tools that you register with your agent. Any questions about that? That's like a lot very quickly.
So these decorators here are defined for the agent class?
Yes, that's correct. So if I go to the previous slide, support agent was like our initialized agent, and then I can say at support agent dot system prompt. I'm gonna like augment it, and then support agent dot tool. I'm adding a registered tool.
So in theory, if you have multiple agents using the same system prompt, you need to repeat that.
You can also define them in other ways. We provide ways to just pass in like, define your system prompt function, and then you can register that without the like decorator and redefining the function. We found that like a lot of users prefer this like decorator approach, but definitely understand that there's like different needs, especially with repeated patterns. Yeah.
Does the agent support like local small language models as well?
Yes. So we have on our documentation we have kind of a list of all of the model providers that we support. And then a lot of the like smaller local models are like from Olema, for example, or OpenAI compatible. And so you can use our like OpenAI model and structure to like make requests to those models. We provide like base URL specification support, and then you can kind of direct things from there.
Okay, awesome. So I just want to make sure that I'm understanding this correctly. So the entire like kind of coercing the model response to be a structured way, that's only if we use the agent through agent class. Like we can't say pass Pydantic AI like an output from another. Okay, got it.
Yep. So I will say like, you know, the SDKs for these model providers, I'll use OpenAI as an example again, provide like an argument if you wanted to go kind of use their low-level API for like chat completions to provide that JSON schema structured output. But we are kind of providing it in this like model agnostic way. I don't have time to touch on like everything that is Pydantic AI, but where a lot of the value comes in is the model agnostic nature, which means you can build these like systems of agents that can pass data from one to the other, and it's like all in this standardized format, which you know takes the form of Pydantic models, of course, or at least is validated as such. And then I don't have examples on the slides, but we just released Pydantic AI Graph, and we even use it internally under the hood of our agent class, which makes orchestrating like multi-agent applications even easier in a like kind of big organized state machine context. Still type safe, but I would recommend if you like have any other questions about Pydantic AI, obviously feel free to ask me or head to our docs, which have some good like demonstrative examples. This one like all on one screen, which is kind of nice as well.
Amazing. Thank you.
Okay. I'm going to move on to the conclusion, unless if people have like Pydantic AI specific questions, I can answer those as well.
I caught a library called Instructor AI.
Yeah.
Kind of, how do you think about that? Is it competing, a sister project? How do you think about that?
Yeah, I would say more like sister project. So Jason Liu, the author of Instructor, is like a huge Pydantic advocate, and that kind of is reflected in the library itself as well. His talk at the AI Engineer Summit last year was like, Pydantic is all you need. And then he gave another one that was, Pydantic is still all you need. So we're like very friendly with Jason. I think we're kind of extending the library, again, with like the graph support and things like that, in a direction that's a little bit more observability focused. So I think Instructor laid some really important groundwork for like, here's how you use Pydantic models effectively with LLMs. And now we're kind of taking in a direction of like, let's do that with, you know, first-class type checking support, and then also integrate with things like open telemetry and make it really easy to use with our commercial products. Yeah.
This is like less a question about like using Pydantic, but more about like Pydantic's role in the Python ecosystem. So like you highlighted at the beginning of the talk, like Pydantic's used by a lot of companies. And I remember, I think it's a few years back now, there was something where a feature of Pydantic was going to like mess up something that was happening in a Python release. Like some PEP. I forget the details now, but I guess, did you expect to be in a place where like you were kind of like such a big part of the Python ecosystem? Like, was that a goal from the start? And now that you're here, how do you responsibly add to Pydantic while like knowing that like the decisions you make could have ripple effects within the larger community?
Yeah, that's a great kind of series of questions. So I won't like fully speak for our CEO, Samuel Colvin, who like did the initial write of Pydantic. But I think it was not anticipated that it would be like this disruptive or influential in the Python community at first. I think it was really built, you know, kind of on first principles thinking, like what is the need here for a specific application? And then turns out that need was present for lots and lots of people. I think in terms of the like conflicting initiatives with like Python sort of thing, it used to be relatively unconventional to enforce types via type hints. Like that kind of goes against the like dynamically typed nature of Python. I think that has just become more standard practice and more accepted, and so I think that like reduces the friction a bit. Just as like Pydantic support has grown, the like adoption and support from like the general Python community or like Python development community has grown as well. In terms of like steps forward, it's definitely challenging. I didn't expect my like personal open source job to be spending a lot of time like considering breaking changes and like considering new typing structures released in recent Python releases that aren't available backported, and like how do you juggle that? So I think especially with a little bit of the friction that came from the V1 to V2 release, we're just trying to do our best to like offer highly demanded features and support like the full range of supported Python versions, but also not like take steps before they're supported in official Python, because then it makes it more difficult down the line.
Thanks.
Yeah.
What is the business model for Pydantic, the company?
Great question. I will get into that very shortly. Okay, so a couple of like takeaways here. You can read these. I'll post the slides later, but sort of said all those things. Also, on the open source note, obviously I'm a like very big open source advocate, but if you're interested in Pydantic or just other tools that you use for free, maybe pandas or any of those like from Blink, import Blink tools, they're open source, and you can help with asking questions, reporting bugs, opening pull requests is maybe the coolest and most helpful thing to do. Answering questions is great, and then writing and improving documentation. Okay, so now I'll answer your question. So today's sponsor is Pydantic Logfire. So now I'm going to get confusing with the terminology. I work for the company Pydantic. We maintain the Pydantic open source package. We also maintain Pydantic AI, and our commercial product is Pydantic Logfire. Pydantic Logfire is an observability platform, and we kind of had this catchphrase of like, find the needle in the stack trace. So our observability tools are general purpose observability tools with first-class support for generative AI applications. As observability demand increases in that space, we look to further invest in Pydantic AI and then the integration with Logfire. So we're unique in a couple of ways. A lot of people are very used to logging that is pretty one-dimensional. Like you have an issue and you get a log that says like, hey, here's your timestamp and your log level and your issue. But we find it much easier and more intuitive for developers to debug things if log structures or logs are structured just like code is, right? So you're like seeing your request, and then you're seeing your response and the validation of that response, and then where things go awry kind of in that nested structure. We obviously offer like very aesthetic displays of Pydantic models and integrations with many popular generative AI tools. I'll show you a photo in just a moment of kind of what our tooling looks like. I mentioned OpenTelemetry earlier. That's kind of the open source standard for observability and makes it easy to integrate across platforms. I guess the last thing I didn't touch on here yet is we offer SQL query access to your data, which is also pretty unique. Like usually if you're searching through logs, you probably just have like a couple of like toggle like filters, which can be a little bit difficult, especially if you're trying to figure things out quickly. Yeah, okay, so this is what the dashboard looks like. It's a little bit outdated, but you have this like live view, and then in that kind of middle panel there, you can see where our tool comes in and is very helpful for like performance bottleneck identifying and things like that, and then the like details panel on the right side. We have an abundance of documentation and videos, etc., kind of demonstrating why Logfire is so helpful. But yeah, so Pydantic pizza today as well.
Is Logfire hosted?
So we currently host all of it, but we're working on self-hosting now. Yeah.
And does Logfire intend to implement persistence, retrieval, and presentation of log data full stack?
Yes, that's correct.
Okay.
Yep. That is all that I have today. There's a lot of different ways to put Sydney Runkle on a screen, and then a lot of links. We have Pydantic docs, which are very robust and have a lot of examples, AI and Logfire docs as well, and then our main sites.
Thank you.
Sydney, thank you for the talk. Thank you for the pizza. Any last questions for Sydney? There's a lot happening here.
I have a silly one. I stumbled recently on Pydantic V1 that I have to say extra equals false. I have to opt into that. Is that switched the other way around in V2, or do I still have to turn off I gave too many parameters in my model?
Yeah, so extra is typed as, or set as ignore by default, and then you can set allow or forbid,
Okay.
but ignores the default.
Thanks.
Yeah,
Are you planning to post the slides online or talk online by any chance?
I can do that. I can either send
Yeah.
it to you or just.
Usually what we'll do is we'll post them as a comment on the meetup event page. That works, or at least a link to them, they're probably on here.
Anything else? No. All right, thank you all for coming. We do not have to leave yet.